Hi there, I'm Alex from Alex the Pie Guy, and today we're doing the practice problems that pair with the 7th lesson of the first section of the grade 9 mathematics academic course. In that lesson, we talked about adding and multiplying polynomials. Specifically, when we were multiplying polynomials, we were talking about multiplying a monomial by a polynomial. In these practice problems, we will just go over some practice examples of times when we would be adding polynomials and we'll be multiplying polynomials, and I'm going to include some bonus problems that have to do with the aside of that lesson. So first up, we have these two polynomials and we're just adding them. So this is a nice easy one. There's nothing being multiplied, so we can just drop our brackets. And now we can collect like terms. There's an x squared term, and there's an x squared term. That's 1x squared, that's 3x squared. So we have 4x squared. Here we have a positive 2x and a minus 7x, so we'll have minus 5x. Positive 1 and positive 2 means we get positive 3. That's the first one done. Nice and fast, nice and easy. Next, we have a multiplying example. So remember, we're going to multiply this guy onto each of the terms in the polynomial. So we're going to get minus 2 times 7 is minus 14 times x. Minus 2x times minus 5x. This is going to turn the minuses into positives. And we're going to be left with 2 times 5 is 10. X times x squared is x cubed. Minus 2x times minus 3x cubed. Those negatives change to a positive. 2 times 3 is 6. X times x cubed is x to the 4. And that's it. Really fast, really easy. On to the second example here. Minus x squared times x cubed minus x. End bracket minus x open bracket times 4x cubed plus 5x squared minus x to the 4 end bracket. So here we have some multiplying and some subtracting or adding, as you might think of it later. As a side note, you'll see I've done this weird indenting thing where my first line starts here, my second line starts here. That's the convention in mathematics for if you need to use a second line, you don't indent the first one, but you indent the second one. Kind of like the reverse of what you would do in maybe your writing classes, where you're writing a paragraph, you indent the first one and you don't indent the rest. In mathematics, it's the opposite. You don't indent the first one, but you indent the rest. First up, we're going to expand these multiplications. So negative x squared times x cubed is going to be negative x to the 5. Negative x squared times negative x is going to become positive x to the cube. Negative x times 4x cubed is going to be negative 4x to the 4th. Negative x times 5x squared is going to become negative 5x cubed. And negative x times negative x to the 4 is going to become positive x to the 5th. Now you'll notice that after the multiplication, our brackets have dropped and we're not looking at the addition of two polynomials, we just have a bunch of terms. So really, although this was a multiplying by monomial and then we're adding the two things, you can think of it as just we're doing two monomial multiplications and then we just collect the like terms, and there's just a lot of terms to collect. So first we have minus x to the 5 and positive x to the 5. That's going to be left with 0x to the 5, but there's no point writing that because 0 times anything is going to be 0, so we can just omit that term. So if these guys cancel out, I like to throw a line through them to make sure that I know that that's what happened. X to the cubed minus 5x to the cubed is minus 4x cubed. And then we're just left with an x4 term, so minus 4x to the 4. And that's it. Pretty fast, pretty easy. Next up, we're going to get onto those harder problems. So if you want to stop here because you don't want to see them, that's totally fine. I'm Alex from Alex the Pie Guy. Remember that if you like this kind of content, drop it a like. If you want to see more, maybe drop a subscribe. Leave a comment to tell me if these problems were helpful in your understanding or if you would have liked to see some more problems. I'm totally willing to put out more videos if that is what people want. I'm Alex the Pie Guy, and if you're not sticking around, then I will see you in the next one. Next, we go on to the harder problems. In these first two questions, we have some FOIL problems. I really wanted to include some of these harder problems in this practice problem set because I know when I was in grade 9, I was actually taught the FOIL method. So I just want to make sure that if any of you guys are learning the FOIL method in grade 9, that you have some practice problems that you can look at and see what's going on. So our first one here, we have two linear binomials or degree 1 binomials. So we have x minus 1 and x minus 3. We do the first items, multiply together, x and x gives us x squared. Now we do the outer items, which is going to be negative 3 times x, which is negative 3x. Now we do the inner items, negative 1 times x is going to be negative x. And negative 1 times negative 3 for the last items will become positive 3. Now we collect like terms and we get x squared minus 4x plus 3. On to the second problem. Now I've switched up the variable. We're not using x anymore, we're using w, just because I felt like it. And we also have a degree 1 binomial here, but this is a degree 2 binomial. So we're going to get a slightly different form in the end. First up, we multiply the first items together. 4w squared times 3w is 12w cubed. We get cubed because this is a square and this has a imaginary 1. So we add the exponents, we get 2 plus 1, and that gives us the 3. Now we do the outer items. 4w squared times positive 2 gives us positive 8w squared. Now we do the inner items. Negative 1 times 3w becomes negative 3w. And the last items, negative 1 times 2 gives us negative 2. Now all of the w variables have a unique exponent, so there's nothing we have to group up together. So this is actually the final answer, which is kind of nice. For the last problem we're going to cover today, we have a bunch of things being multiplied together. What this will turn out to be is we're going to have that case where we are multiplying two larger polynomials together in a case that FOIL isn't necessarily useful. So if that is not in your mood and you want to pop out now, that's totally okay. I totally understand it. For those that want to stick around, let's continue with this problem. So we have 2n cubed times n minus 6 times n plus 1 times n minus 2. The nice thing about this is we can multiply each of what we call these factors in whatever order we want to do them in. I'm just going to work from the right and I'm going to work left, and we'll see where we get. So I'm going to write these first two what we call factors down, because I'm not going to touch them yet. I'm just going to worry about these two multiplications first. Now here we're multiplying two binomials, so we can actually use the FOIL method in this part here. So n times n for our first items is n squared. The outer items gives us minus 2n. The inner items gives us positive n. And the last items gives us minus 2. Now I'm just going to combine these two right here, save myself a little bit of room. That just becomes minus n. Next up, I'm going to multiply this factor into here, and it's going to be multiplied onto each of these. So I'm going to write this first, minus 2/3. I'm going to use a big square bracket because I'm going to use a lot of space here. And this is going to be n squared times n minus 6 minus n times n minus 6 minus 2 times n minus 6. And now I just do a bunch of monomial multiplications. So n squared times n gives us n cubed. N squared times negative 6 gives us negative 6n squared. Negative n times n gives us negative n squared. Negative n times negative 6 gives us positive 6n. Negative 2 times n gives us negative 2n. And negative 2 times negative 6 gives us positive 12. Now I could do the next monomial multiplication and multiply this monomial times each of these terms. But instead, I'm going to actually collect like terms here. It's just going to end up being less multiplying I'm going to have to do. So we only have one n cubed term, so we just write that, n cubed. There is two n squared terms, negative 6n squared and negative n squared. That gives us 7n squared. There's two n terms, so this is positive 6n minus 2n becomes positive 4n. And there's only one constant term, and that just gives us 12. Now we can do this last monomial multiplication. And doing this, I can actually drop the brackets, so I'm going to be left with 2n cubed times n cubed is n to the 6. Remember, we add the exponents, not multiply them, which some people tend to do. We add the exponents. Now, 7 times 2 is 14, and that was negative, so hence we have the negative still. N cubed times n squared is going to be n to the 5. Again, we are adding the exponents. 2n cubed times positive 4n is going to be 8 n to the 4, and 2n cubed times positive 12 is going to be positive 24 n cubed. And that big mess, after all of this work, is the final answer. Anyways, that's it for these practice problems. I hope you liked these practice problems, and I hope these bonus problems were helpful for the people who wanted to learn more or who are going through some more advanced things that their teachers are teaching them in their grade 9 course. I didn't say it in the lesson video, but this is actually the end of the first section. The second section is going to be on linear relations. So I am looking forward to sharing those lessons with you soon. Anyways, I'm Alex from Alex the Pie Guy. If you like this kind of content, it'd be awesome of you if you could smash this like button down below. If you'd like to see more of my content, you could drop a subscribe. And I would also like to hear from you in the comment section below. Tell me what you liked, tell me what you didn't like, and tell me what you'd like to see more of. I'm Alex from Alex the Pie Guy, and I will see you in the next one.